Hello, hi, this is Tushar. So this video is for the advanced encryption algorithm implementation on FPGA. So in this video we will going to simulate all these files that we have seen so far to check whether uh, we have implemented the right code or not. So to do that, um, so this is our work library, and under that under work folder we have different files here. To be able to simulate it, we need to compile first. So we can compile different file and to do that we have this prompt here. We can see this prompt. Alright, let's do pwd present working directory. So that is C Altera 14.0 AES, and that's our present working directory. It's like Linux pwd. Then if we do ls, then we have different files, right? AES 128, top, algoround, keygen, all these files. So then we have to compile different files. Suppose I have to compile this top file, right? If I want to compile, I have already compiled all of them, but let's test one of them. vcom to compile, then top.vhd, then enter. So it would compile the file, this top.vhd, this file. So we can see there is no error. It just has one warning, which is fine. But if there is an error, any kind of syntax error or something, it will show us here while we compile it. Right, so once we have all the files compiled, then we can simulate it. To simulate, here we can right click on top, right, and this simulate, the first option, select it. Right, so we have the simulation started. Okay, so we have one more tab here, the wave here. Here we need to add all. Okay, starting from left hand side, we have this top file and their corresponding different signals. Right here, all these are signal of top file. Then we have key generator and their signals, right, all this from key generator. Then round and their signals. Okay, then if you want to verify, right, this round and key generator we have here under top. This is a hierarchy, right? Top, under top we have key generator and round, that is here, key generator and rounds, right? And this is the file name keygen, and algoround is this one, and keygen is this file, right? So this is how it looks in hierarchy, right? Then next step, we need to add waveforms here. Whatever waveform we want to see, we need to add it first. So let's see, we want to see all the signals from top. Okay. So right click, select them all, right click and say add wave, right? So those are added here, all are from top. Then going to next key generator, and let's say we add the current key, new key, left shifted. I guess we don't need that because it's internal signal, we won't be needing it. Then round constant, yeah, we can add actually all of them, that's fine. Add wave, right, and for the round we have these two signals. Okay, then to run simulation we again need to go to the command prompt and say run 200, we can add whatever number, 200 nanoseconds suppose, right? 200, let's see, we run for 200 nanoseconds. So what happened in those 200 nanoseconds we can see when we enter, right? Okay, so now we have waveforms here. If I click on this one, zoom full, right, it will automatically adjust those waveforms here. So then we need to zoom in. Okay, we can see different signals here, like the count signal, right? So this is a clock signal which is going from 0 to 1, 1 to 0, right? It's like clock 0 1 0 1 0 1 0 1. It is continuously changing. That is because we have this code here, this code. Clock is not clock after 5 nanosecond, so after each 5 nanosecond the value of clock would be changing. That's why we have 0 1 0 1 0 1 like this. Then reset signal. So this reset signal, for reset signal we have reset signal is assigned to 1 for initial 35 nanosecond, and then it goes to 0 forever because we have wait until false. So it will stay 0 forever unless we change it. So this is for simulation purpose, right? So reset signal stays 1 for initial 35 nanosecond, right? Here we can see it's in picosecond, however, right? As we move cursor it will change the value, and then it goes to 0 here, right? This falling edge we can see. Then the count will start counting once the reset signal goes to 0. Then on each clock cycle it will count, the count will incremented by 1. So this is 0, then the value is 1 here, 2, 3, 4 and so on. That count value will go all the way to 10, right? And once we have 10, on the next clock cycle it will again go to 0 here and start counting again to 1, 2, 3, like that, right? So that is count signal. So this first this 3 signal is basically driving the whole algorithm. Based on this count signal, we are making many decisions what to do. Okay, then this is a key signal. So this is the value of key. Here it's all zeros and 1, it's all in binary, but we can change the radix, right? If we change the radix to hexadecimal, it will be nice to in terms of reading, it will be easy. Now we can read something 0 0 0 1 0 2 0 3 0 4 0 5 0 6 up to 0f, right? That's the value of key signal, which is here. The key signal, this is what we have assigned, 0 0 0 1 up to 0f, right? So that is being reflected here. Then this is the generated key. This is the output of the key generator. This is the output of key generator, right? So we'll see that. So this is a current key. Current key is what we've been passing. Let me change the radix hexadecimal, right? So this is the key, that's what we are passing to the key generator as a current key, right? So when the count is 1, we are having the current key equal to the original key 0001 0f, right? Then on the this is new key. Let me change all the radix to hexadecimal. Then new keyword. Sorry, there was a fire truck outside. I'm just sitting beside the road, so because my house is on the road, so sorry for that. Okay, so let me zoom in a little bit. Okay, so on count 1, the current key is the same as this one, right? Then we have the new key, which is being generated from the current key. That is the first key, right? So that is D6AA74FDD2A. That's the one. To verify that whether we are generating right key or not, I have one website here, right? That is crypttool.org, and here we choose what configuration we are using, that is AES 128, right? Then I have the key value, which is 0001 that I have shown already, right? And based on that key value, it will tell me what should be in the expanded key values. So this is the original key, these 4 words. The next 4 words would be the first generated key, that is D6AA74FD. we can see here D6AA74FD, D2AF72, right? That we can see here D2AF72. yeah, so this is the expected output for us, and I have already cross-verified it that I did successfully generated all the keys, all 10 keys.